My name is Jonathan.
I'm Caleb.
I'm Dylan.
I'm Dean, and we are the ultrasonic tracking platform, team number 99.
Have you ever wanted to track something? Have a flashlight follow you through a dark environment? Entertain your pets while you're away? Scare off an intruder after hours? If so, you're looking for a tracking platform. Let's explore Team 99's modular tracking platform, powered by a robust Arduino system. A solid 3D printed base supports a bespoke Arduino system powered by common consumer batteries. An ultrasonic sensor mounted forward scans the environment for objects. And in this configuration, when an object is detected, the motor releases a rubber band. The platform effectively scans up to 180 degrees.
So, when it comes to the circuitry, we are powering it off of, as Dylan said, a 6-volt battery pack using common AA batteries. And the main motors are 2 stepper motors. One used to turn the base, and the other is used in this configuration to shoot the rubber band. The actual 3D printed form was produced from a Bamboo X1 carbon 3D printer using PLA. It's designed to be lightweight, yet strong, and it is also designed for stability. As you can see here, it has a bevel to stop it from moving off axis, and it is, as Dylan once again said, strong and lightweight.
And here we have some of our code snippets. So this right here is our main for loop. So right here, this top line checks if the button is pressed. That'll start the main process. It's going to iterate through the for loop, and it's going to start sending it each time through the for loop. It sends it 1 degree further around the rotation. Here we're getting the distance variable from the ultrasonic sensor and comparing it to the previously recorded distance. And if it is less than that, it's going to save that as well as the current angle it's at as the new distance, as well as the angle go to. And then just right here, we're stepping through. Here's the fire function we wrote. So this was tailored specifically for the trigger stepper motor, and it starts at 100, and it'll go through just 2 steps on the motor to activate the double action trigger and fire the rubber band.
And so here's the flow chart that we did for the hour logic. So if the button is pressed on the Arduino, the DC motor does a 180 degree sweep around, and while it's doing that, the sensor detects like all the distances. And so if we have a minimum distance that we set for our code, and so if the distance that the sensor detects is less than the minimum, it saves that distance as the closest distance. But if there's a new distance that's less than the other one, the previous one, it'll save that distance instead, and it'll save that angle. And so then after it does the 180 sweep, it'll go to the angle with the closest distance and activate the shooter, and then it'll just go back to its starting position afterwards.
And now we'll move into the demonstration portion of this.
Alright, ready to start? Alright, so another thing for modularity, currently in this configuration, we are just using Lego piece to put our desired function on top, which in this case is a rubber band gun that we use a stepper motor to control. For any end user, you could use multiple different attachments methods because this is just a flat surface on top. We are also using a stepper motor currently, which is useful for a variety of things, but could be swapped out for anything that the end user wants. Another configuration of this setup could be using a transceiver on bottom and top to separate the circuitry, meaning that these wires would no longer be here, which would allow full 360 degree movement, as well as more options for the end user on top, instead of having to use the limited pin space on the current Arduino. They could use their own or their own PCB in general. But now we will demonstrate what this prototype is capable of. So as I press this button, it'll start the scan, I'll hold my hand out here. I'll show that as the closest. And then it will fire the rubber band, and then it will continue doing the scan.
Wow.
As it goes.
And another thing we've considered too is, as well as swapping out that for something else like a laser pointer, you could also swap out the ultrasonic sensor for any number of components.
Yep.
Thermal scanning, LiDAR, even a camera. So it's just a great modular base. So yeah.
And if you wanted a 360 degrees of movement, you could incorporate some radio technology to
Yes.
get rid of these wires.
Exactly. Cool.
Yep.
Thank you.